Hello students, we are starting assignment 7.3 and in the first video we will discuss RMS voltage and RMS current. There are 7 questions in this assignment and we will be dealing with these 7 questions in 3 or 4 videos. In first video we have just one question, 11th question, which is derive expression for RMS value of voltage for AC circuit. Write expression for RMS value of current for AC circuit. So let us start. We know that in AC circuit, voltage can be expressed as V is equal to Vm cos omega t. You can also express it as V equal to Vm sin omega t. For now, we consider Vm cos omega t. Now, if we plot this voltage, this is voltage at time t, so it is called instantaneous voltage. So if you take graph of voltage versus time, you will see that the graph comes out to be like this. So whatever number of positive values you have, same number of negative values, and hence if you take summation of cos over one cycle, you will see that the answer is 0. So what is the problem? Problem is, if I try to find out average voltage, if I take average voltage of V equal to Vm cos omega t over one cycle, it will be 0. And hence, if we are asked to find out or express the voltage value mathematically, we cannot say that average voltage is having something value like 100 volt or 200 volt or 250 volt. Okay, and you cannot measure this voltage with DC voltmeter because voltage is changing with time. So to solve this problem mathematically, first square of this value is taken. Once you take square, you will not have any negative values, all values will be positive. So then you can take square root, then you can take average of the squared values and then you can take square root. And the value obtained in this way is called RMS value. What is RMS value? So what we do is first take square, then take mean or average, and then take root. So if you look at this order, it is called RMS. So to find out RMS value of the voltage, what you have to do is you will have to take square root. Square root of what? You will have to take square root of average of V square. Okay, so that is RMS value. So first we will start with taking square. So V square of equation 1 is Vm square cos square omega t. Now first stage is over. We have taken square. Then next is take mean, average. How do we take mean of something? So whenever you have continuous value, to find average, normally what we do is we take summation of all the values and we divide with total number. But when it is continuous value, like in this case, where we have continuous values of function of cos, in that case, to find out average of say v square, what you have to do is you have to take integration of v square over time and then divide it with total time. So average v square can be given as integration Vm square cos square omega t dt, and as we are integrating from 0 to total time period, we will divide this with t. Okay, and Vm and t being constant can be taken outside, so we will have Vm square by t and integration of cos square omega t dt. Limit of integration is from 0 to capital T. Now there is one trigonometrical identity which I'd like to show here. If you have cos square theta, if you have cos 2 theta, you can write it as 2 cos square theta minus 1. So if I make cos square theta subject of formula, it will be 1 plus cos 2 theta by 2. Okay, and this is what we'll be using here. Why? We'll come to know soon why to do this. So Vm square by t and integration 1 plus cos 2 omega t by 2 into dt. Limit of integration is from 0 to capital T. Check here, instead of theta we have omega t. Okay, so now I can take this 2 outside, and then what I'll have is Vm square by 2t, and I'll divide the integration into 1 dt plus integration cos 2 omega t dt. Now again, see, when you take integration of cos over one cycle, what you are doing is you are summing up all these values. And what should be the answer then? Answer has to be 0. So this integration will be reduced to 0 provided you are summing it up from 0 to capital T. Over one cycle, summation will be 0. So it's not necessary that integration of cos theta is 0 always. As we are taking integration over one cycle, it is 0 in this particular case. What about the first integration? So we'll have to deal with. Let us deal. So average of v square is now vm square by 2t t limit is from 0 to t. What I have done? Integration of this one, integration dt is t and limit is mentioned there. So now what will be the bracket? It will be capital T minus 0, that is capital T, and ultimately I'll be left with v square as vm square by 2, and I'll call it my equation 2. So I have got my uh, let me rewrite this. So what I have got now is average of square of voltage, which is Vm square by 2. Let it be equation 2. And now if I take root of this, I'll get Vrms. So Vrms is root of average of square, and hence Vrms will be under root of Vm square by 2. Equation 2 I have used here, and then Vrms is Vm by root 2. Okay, so whatever is the peak value you have here, suppose if it is 200, suppose Vm is 200, what you have to do is take 200 square, and that is RMS value of this voltage. So in AC circuit, current and voltage both are expressed in terms of their RMS value. If you have current, you can express current also in similar way. IRMS is Im, that is maximum value of current, by root 2. So that is all we need to know about RMS value of voltage and current. Thank you.